Hi everyone, Mrs. Besega here, and today we're going to learn how to calculate the friction force. Now, as you recall from last Wednesday's video, we used a applied force versus friction force graph and got three distinct regions. The static region, in which the friction force was always equal to the applied force, and this was because this was at static equilibrium. Think of it like this. If I put an applied force to the right, and it was not balanced by the friction force to the left, then it would accelerate. These have to be balanced because they're in equilibrium, guys. But if I put too much force on it at that threshold of motion, if my applied force is large enough, then all of a sudden it starts to move. The threshold of motion is the maximum applied force that you can put on this system in order to start or in order to get it out of static equilibrium. Symbolically for that, we write that as F sub friction static max, and this is where it switches to moving or kinetic friction. Keywords to look for the threshold of motion would be start moving. Finally, the last region is the kinetic region. I've heard people call this kinetic energy, and guys, you want to avoid that. Kinetic simply means moving. This is the constant amount of friction that two solid surfaces feel as they slide past one another. As long as they're moving at any velocity relative to each other, that constant value of kinetic friction stays the same. So static, threshold, and kinetic are three distinct regions of this graph. And so what we're going to do is we're going to write one big piecewise function. It looks something like this. For static equilibrium, the friction force is equal to the applied force. At the threshold of motion, the maximum static friction force is equal to mu, the coefficient of friction, times the normal force. I'm going to use TOM as my abbreviation for threshold of motion. Finally, that friction force kinetic is equal to coefficient times normal, but we just select the kinetic coefficient instead of static. These three equations together give the one piecewise function that works for friction force. So sometimes you'll see people shorten the friction equation to just look like friction is equal to coefficient times normal. But we can use this to help think back to what this means qualitatively. If I wanted to make friction lower, then I just need to lower either of those two variables. I could change the coefficient by adding oil or smoothing the surface or changing the surface. But I can do lots of things to normal force.
Anything that lowers the normal force would also lower the friction force. So I could bring it to the moon, right? Less weight, less normal force. I could float it on an air hockey table. You can't have normal force if they're not touching. We could put it on a ramp or in an elevator. We could lower gravity. Any of the ones on there would lower the normal and thus lower the friction. So let's sum up what I want you to know about friction. I want you to know that friction can change values depending on how hard you push it. If you don't push it hard enough, it will stay in static equilibrium and not move. If you push it harder than the threshold of motion, then the friction force drops down and it becomes easy to keep that object in motion. Kinetic friction is always lower than static friction. Finally, I want to be able to describe the factors that affect friction. On one hand, we can change the coefficient of friction to minimize the amount of friction two surfaces have. On the other, we could change how hard those surfaces are pressed together by lowering the normal force. This has real-world implications for things like lubrication or moving objects, things that people actually come in contact with in their day-to-day lives. So fill out the Google form associated with this, and I'll see you soon. Best of luck.